Dr. Satish will be presenting on 5G core network and architecture. This first session will be conducted by him, and we will be having this session from 10 o'clock up to 11:30. So please go ahead, Dr. Satish. Yeah.
Okay. Good morning all. Today we are going to have a session with 5G core network architecture. So in this session we are going to see the fundamentals regarding core network and components and architecture in the 5G core network, and we are not going to see any advanced thing related to your core network, because the reason for this session to teach the fundamentals is today in the third session you have a video demo session. There you will be having a entire 5G access network and core network. So I'll be introducing all the fundamentals and the architecture related to 5G network. So with this I'll move on to the presentation. So in today's scenario, first we'll start with the evolution of cellular network architecture. So how this cellular network architecture, particularly with respect to core network, how it evolved from 2G to 5G. Next we'll be seeing the key focus and enhancement of 5G NR. So 5G NR is nothing but new radio here. Next we'll be seeing the core network architecture, service based architecture, CUPS. So control user plane split architecture. Then we will be seeing the interfaces of your, what are the interfaces presented in the 5G network with core network and access network, everything. Then deployment scenarios, whether it is going to be a standalone 5G architecture or it going to be a hybrid interconnection with your 4G architecture kind of thing. So finally the 4G 5G core network connection. Then how the data flows. So what are the QoS parameters and their characteristics, how they behave in this 5G network. And finally we'll be seeing the network function virtualization. This is a very, very important topic in the 5G and virtual network function architectures, and finally we will end up with the network slicing. So with this we'll move on to this slide. So evolution of network architecture, cellular network architecture. So in 5G access network also you will be seeing the same figure. So what I'll do is today I'll neglect this access network. I'll deal only with the core network. So starting with this, so it starts with your 2G. Okay, so 2G network, first it started for only for your voice services. So voice services was given for voice services or circuit switching services only HLR, home location register. So this contains all the equipment identity register and authentication user center, and GMSC, gateway mobile services center. So it deals with all switching function, everything, and MSC, message switching center, or your visitor location register. So this is only for the voice services. Later on from 2G we moved on to 2.5, 2.75. That means you added the data services to your 2G network. So then comes SGSN node, that is serving gateway supporting node, and GPRS gateway supporting node. So this takes care of your packet switching. So circuit switching, packet switching combined, it took place in your 2G GSM. Later on then it has been connected with your local PSTN, that is public switched telephone network. This is a background network or backhaul network, whatever else. Then we moved on to your 3G U-Tron. So U-Tron, U stands for UMTS, and T stands for terrestrial radio access network. So again UMTS is nothing but universal mobile telecommunication system. So in that also circuit switching, all the same nodes, HLR, GMSC and MSC, VLR, everything has been present here. And here the packet services are more GSN and more SGSN we found in this. So more or less the 3G network architecture is similar to your 2G core network architecture. Only difference is all your BSCs has been replaced by your radio network controller, and base stations have been replaced by, sorry, this is only NB, it has been written as NB. So only the introduction of node base stations and the radio network controller. So more innovations has been in your access network compared to your core network. So later on we moved on to the 4G E-U-turn. So E stands for evolved. U-turn I specified already, UMTS, terrestrial radio access network. So here there is no radio network controller. Only the node base stations has been now evolved to ENBs. Okay, and here all your MSC related services. Okay, it has been done by the node MME, that is mobile management entity, and this is connected with your HSS. The HSS is similar to the HLR in your 3G and 2G networks. So in this HSS, you have the equipment identity register, your authentication, everything is there. Your entire data network, because evolvement happened only in your data services. So instead of this SGSN and GGSN that has been evolved to the new nodes, SGSN. So here itself I told you that serving GPRS support. Now that has been moved to serving gateway, and your GGSN. Gateway GPRS supporting node has been moved to P gateway. P stands for PDN, that is your packet data network. So it all this has been evolved into the new function system, and here we introduce the new thing, this policy charging rules function. This is regarding your 2G services and 4G services. So how much data you have used in your 4G network, everything. So it continuously gives such information because based upon the packet data a customer is using, your policies or your charging regarding your policies, everything is been given to the UPG, and all this data network, okay, in background it has been connected. Here the background network is IMS. IMS is nothing but Internet Protocol Multimedia System, IP Multimedia System. So for 4G system, your IMS system is the background, whereas your 2G it is PSTN, public switch telephone network, whereas in your 3G network it is just a very beginning internet protocol networks. So now moving on to the 5G, okay, there is no much innovation made in the access network because access network has been discussed in the last class. A evolved node based station has been moved on to the next generation. So G stands for generation, NB for node based station. So generation node based stations. Okay, 5G NR is nothing but again new radio. So here the MME component, okay, yes, it has been replaced by two functions here. One is your AMF and second function is your SMF. AMF is nothing but access mobility function. It is similar, it performs 50% of what MME does. And second one is session management. Session means regarding this your dialog controls between different sessions, all those things. So MME has been divided into SMF and AMF. Next, the serving gateway. Okay, the serving gateway has been modified to your UPF, that is user plane function, and your PCRF, okay, policy charging rules function has been, now it has been changed to PCF and AUSF, and these are the other new functions have been added to your 5G network based upon the application function. So this now your background network here is application function. In 5G, day to day new services will come in. So based upon the new application and new services, there will be some minor changes in your architecture. So it will be migrating to a more diverging architectures. So based upon the diverging architectures, it is evolving. More and more number of functions have been evolved. If you see here, there is no, all the functions have not connected to a common plane. Whereas in 5G, if you see this line ended with dot, all the major functions have been, all the control functions have been shared to a common interface of the control plane. Whereas this is not placed in your 5G. Anyway, we will see the detailed architecture. So far we have seen the evolution of core network from 2G to 5G step by step. We will be seeing the detailed reference core network architecture of 5G. So 4G LTE core, that is evolved packet core. Okay, from the 4G LTE core, now you are realizing towards your 5G new radio core networks. Okay, this 5G new radio core takes some major functions of your 4G, and it is a completely software and cloud based open platform. Okay, whereas in 4G might be partial, but 5G is a complete software and cloud based open platform. The reason is there are plenty of applications and lot of devices you will be connecting in your 5G, not only your mobile, laptop, your home computers or some other electronic devices you will be connecting with your 5G. That's why it has to be a open and a cloud-based platform. Next one is 4G core EPC elements. Everything is implemented on the physical nodes. They are said to be virtualized, but not designed to be virtualized from the outside. That is, in the 4G architecture, I mentioned MME and PCRF and serving gateway and P gateway, all those they acts as a nodes. Okay, they are said to be virtualized nodes, but they are not fully virtualized. They might be partially virtualized. So that's why it is not designed to be virtualized from the outside. So it is only partially virtualized. Whereas if you take the network elements in 5G, like I mentioned, AMF, SMF, all are functions, and here referred as a function, they are completely virtualized. This is one major difference between your 4G and 5G. In 4G, everything it is represented as nodes. They are not fully virtualized. Whereas in 5G, every component it has been represented as a function, and all functions are completely or fully virtualized. Next one is automation programmability. Okay, this is not better with your 4G. And next one is virtualization. Already I talked about virtualization, and better support for diverging architectures for new services. So based upon the new applications emerging in the 5G, depending on different applications, you will be doing some minor changes. So new architectures come into the picture. So based upon the new architectures, so more new functions, okay, or some minor changes in the old functions come into the it will be evolved in the future thing. So next one is major enhancements. So what are the major key enhancements we have with the 5G core architecture is, first one is service based architecture. So service based architecture means here everything, each function, everything we are calling it as a function and network function. All the network functions are virtualized. Okay, each network function is delivering one particular service. That's why this is a service based architecture. Anyway, I'll explain the service based architecture with a proper architecture diagram. Next one is important as control and user plane split architecture. So control and user plane means among all the functions here, we are separating what are the user functions and what are the control functions separately. This is one major enhancement of your 5G core network. And network slicing is one more characteristics. Due to network slicing, okay, you are enjoying enhanced mobile broadband. This is very useful for your OTT platforms or your mobile TV or internet, whatever you are browsing. Next one is massive mission type communication. This massive mission type communication is very useful for device to device communication or vehicle to vehicle communication, shipping, automotive kind of thing. Last one is ultra reliable and low latency communication. This is for some emergency and critical applications or from medical healthcare kind of thing. So here we have shown the differences between the 4G LTE and 5G NR. I have compared the characteristics. So first characteristic, data rates. So this data rate, whatever is specified, is a peak data rate. It is not the average data rate, peak data rate. So peak data rate at most 4G LTE we are expected to have some 300 Mbps. 5G we are based upon these three enhancements, we are targeting towards 20 gigabits per second. Okay, so till now in 4G we are though we are saying gigabits in terms of data rates, we are not practically we are not experiencing the gigabits experience in terms of data rates. That we are trying to achieve nearly 20 Gbps in 5G NR. Latency, we are having a latency of 10 to 50 milliseconds with your online OTT platforms, or if you are watching any online cricket, those things. So we are targeting towards 1 millisecond. Mobility up to 350 kilometer is achieved in 4G LTE. Now we are expecting something greater than 500 km per hour in 5G NR. Spectrum efficiency, you know that spectrum efficiency is nothing but the ratio of bitrate to the channel bandwidth, that is RB divided by bandwidth. So if you take for downlink, right now we are experiencing 6 bits per hertz. We are trying to target towards 30 bits, 5 times the downlink spectrum efficiency in case of 5G NR, whereas in case of uplink in 4G LTE we have 4 bits per hertz. We are targeting towards 15 bits per hertz, that is 4 times. So downlink spectrum efficiency, we're expecting something 5 times better, whereas uplink spectrum efficiency, we are something targeting 4 times what we have with the current 4G LTE networks. And user densities right now we have 2 kilo, that is 2000 users around around square kilometer distance. We are covering to 2000 users. Now we are targeting towards 10,000 K, that means 10 power 6 users. Okay, energy efficiency, now we have a very moderate energy or power efficiency in case of 4G LTE. Now we are targeting the 10 times what we have in the 4G LTE. We are expecting the better power efficiency. So with this is a complete 5G NR, new radio core network. CN is nothing but core network reference architecture. So there are many 3GPP references are there. I am referring to 3GPP TS 23.50. That particular document thing I am referring. So this is a complete thing. So as I told you, this red color line, this is the common control plane. All the network functions have been interfaced with the common control plane. So whatever function I need, I can communicate with my control plane. And this N refers to the interfaces of the particular function. For example, these are the major functions: NEF, network exposure function; NRF, network repository function. Okay, so these two related to network and management function. So network exposure function is depending upon the new applications coming. Suppose based upon your mobile broadband, or if you are targeting towards low latency applications, you have to slice the network. So that time this you can use this function, network exposure. So based upon the new services, new application, new architecture, this function is exposed. Network repository function. Repository means storage. So there will be something with network management kind of things. You have something to store some credentials or network related some keys. This one, everything will be stored here. This is the corresponding network interface. So capital N stands for the network interface. This small letter subscript refers the particular function. Similarly, PCF, this is similar to your dynamic charging policies. What you had in your 4G, you have PRCF. The same thing is here, it is PCF. Okay, so dynamic policy means how you are using, what is your daily usage, your data limit, whether you are using a 1G 1G free data service, or you are having a 2 gigabits data rate, or you have a what, such kind of policies will be specified in the policy charging function. UDM, this is similar to your HLR or HSS, whatever. So user data management. Here all information regarding your equipment identity register, or your IMSI number or IME number, and your all those informations about the user, it will be stored here. Application function, based upon the application that corresponding, whether you are going to use a video call, or you are going to use audio call, or you are going to browse anything, or you are going to watch anything on your online OTT platform, or else you are going to access any other device in your office or in your home. You want to switch on or switch out those devices. Based upon plenty of applications, you may choose your application here. Similarly, next one is authentication users. One second. Authentication. Okay, authentication server function. So this authentication server function is nothing but, so once user is registered to the network in 5G, you have lot of user authentication is maintained. So once user authentication is maintained, there will be lot of authentic checks, and your ciphering cryptographic algorithms will be there. You'll be checking the ciphering, deciphering of this. So there will be lot of keys involved in all those keys will be regarding your security kind of thing. All those things will be saved in this. It will be handled by this authentication server function. Next one, this AMF SMF, already I told you, your MME, mobility management entity in 4G, has been divided into two things. One is access mobility function. This is directly connected to your GNB. Okay, so all things regarding your signaling thing with your GNB and your communication with the user equipment, mobile or laptop or whatever data service. So AMF deals directly with both users and directly relates with the user through GNB. All kind of signaling kind of thing between the GNBs and the AMF, it take care of all those things. That's why access mobility function. Next one is session management function. It is related with your user plane function based upon the user data or traffic. What kind of session? Suppose he is in a single call, or he is in a conference call, or he is in a video call, multiple call, how the dialogue sessions are going, whether how many users were there in that conference call, if somebody disconnects, whether the person is coming again, all the sessions, okay, between the user or between the different user or between the user and the network, everything is being dealt by this session management function. So there is a split. So user network has been separated and the control plane network has been separated. All the functions related to the control plane have been connected to the common interface. So all the services offered by the 5G network has been connected to a common interface that has been connected to your control plane. So with this, so here we are seeing the major functions of each and every block what we have seen in the last session. So the first one is user plane. We have only one function, that is user plane function. So it will be handling the packet routing and forwarding of all your data packets, and regarding your policy rules, charging rules, it will be communicating with your PCF, and it will be from the PCF it will be getting this information. Once the packet starts flowing, it will be seeing the QoS, quality of service, how the packets have been handled, any packets have been missed, so how many users, what each user, suppose user one, what type of service is using, whether voice service or a data service, what kind of packets, all those things, it has been handled by the UPF. Next one is your data network, is your background internet network. So your user plane network will be connected with your data network. So access and mobility management function, as I told earlier, so it checks the authentication, connection and mobility management between the network and the device. Okay, device here is your mobile phone or your laptop, whatever else, and also it receives the connection and session related information from the user equipment. Okay, so it deals with both user equipment and also with the network. Here the network is nothing but GNB. Next one is authentication server function. This performs the authentication process within the user equipment. Okay, so within the user equipment, nowadays your mobile phone is 2 SIM slots. Okay, so you will be having a 2 IMSI number. If you are using 2 SIM, then you have everything too. So all those authentication verification process, it has been maintained with the AUSF, and this is optional. This particular function I have not shown in the diagram. So this authentication repository and processing function, this comes under AUSF itself. It stores all the security credential keys or security keys regarding your cryptographic or the user authentication. All those keys will be saved under authentication repository processing function. So whenever you need authentication related thing, that time this particular function will be, you can access that particular function. Next one is session management control function. So user equipment IP internet protocol address allocation management, that function has been carried out. Then selection and control of UPF. So there might be in some cases more than one UPF. Then which UPF it has to communicate. All those things has been handled by SMF, and obviously this also connected to the PCF regarding the policing and charging issues. Next, UDM, as I already told, it stores the complete information about the subscriber. PCF is about whether you are using a prepaid network or a postpaid network, whether you have a static policy with the operator or you are having any dynamic policy with the network, all those things given by PCF. Application function, it depends upon the application. Okay, what application you are accessing, based on that you have your policies and the charging control. And already I talked about network repository and network exposure function. So with this 5G key enhancement, I told you the 3 important things. First one is service based architecture. So we will see what service based architecture. So the service based architecture, I already told you, this black color line splits your network architecture into 2 things. One is user plane, next one is control plane. So first user plane. So user plane, all your access network, whether you are going to use a 3GPP services or non 3GPP services, all those things have been communicated with the user plane. And if you see this green color line here, this user plane, mostly it is a point to point links. Okay, from the user plane it will go to the particular function. Suppose user plane, it is going to user plane function, user plane to data network, user plane to, so your different 3GPP, non-3GP activities are there. So it whatever the activities it is connected to that particular 3GPP, it is having a individual point-to-point links in case of user plane. Okay, here non-core MEC. So this is mostly an industry standard. MEC is nothing but the mobile computing, mobile edge computing. This is mostly the industry standard. Okay, right now in our network architecture we are just ignoring it, but if you see, if you are looking at the point of view of industry oriented, that time this mobile edge computing plays an important role. This function of this mobile edge computing is there will be plenty of networks. If you go, if you think any network operator, you'll be providing a plenty of networks here, but a user will be using any one particular network only. So the communication between the different networks, because every network is again a server, so the communication between the different networks provided by the particular operator, that takes care by this mobile edge computing. So right now we will ignore this from our discussion. Now coming back to the control plane, so already I told you lot of functions. Okay, so network manage, so resource management, I introduced network exposure function, network repository function, that comes under here. So all network related services provided here, and it has been connected to the common interface. This red color line is a common interface, it has been connected to the control plane. Regarding signaling, so signaling is given by, I think, your EAMF and SMF, that has been connected to your control plane. Next, location based services, this comes your AUSF, I told you, right, AU authentication server function, that comes under the location services. Next, subscriber management. Okay, subscriber management major function I told you is UDM, it stores the complete subscriber information. So the subscriber services, it has been coming here. Application and network exposure function. Okay, again it is network function has been merged here also. This deals with some new applications. I don't know what are the new applications the user is having. All those things have been connected here. And regarding policy, we have only one function, PCF. So that functions itself is been divided into major services. All the services, okay, based upon the common interface, or you call it as a common protocol, whatever else. So service based interfaces, it is connected to the control plane. So suppose user's identity has to be verified, then the subscriber management will initiate that one. So either it will ask, it will send any request to the control plane. If somebody is requesting subscriber management, then it will verify the information of that particular user, then it sends the reply to the control plane, that will be sent to the person. Or else if some other some dynamic policy related regarding what type of network connections you are using, what are your charging functions, then this particular services, it will be that particular function will be communicating with the service based interface to the control plane. So here it is two kind of services. Okay, one is requesting and replying, or you have to subscribe for the whatever the information you want, and later on you will be getting notified. This is called service based interface. Okay, either request reply case, or else you can subscribe for the information what you want to need, then later on you will be getting that information through your mail or your SMS or whatever else. Okay, all those things has been connected to your IMS core. So IMS core is nothing but again IP, internet packet multimedia subsystem. This is a backbone core network with your 5G architecture. So with this, so this service based architecture, it has been defined in TS 23.50, this specification I refer. So service based interfaces between the control functions, I told you right in the last diagram, the red line, all the functions have been communicating with each other and also with the control plane with the help of service based interfaces, and user planes connect over the point to point links. So one more advantage of this service based architecture is if you see in your 2G or 3G, or there you will be having many application layer protocols like a diameter protocol, radio. If you have worked in the network layer, you will be come across this one. All these things have been replaced here. We are using only hyperlink HTTP protocol. So HTTP protocol is nothing but hyperlink hyperlink text protocol. Hyperlink text protocol, and everything is based on, since this is application layer protocol, it is based on application program interface. Okay, it replaces that all that SS7 protocol into your 2G GSM, and this diameter protocols, radius protocols in 3G, everything, it has been replaced by your HTTP. This protocols also nowadays, it is application program. Protocols also communicated through interfaces, which is not possible in your either 3G or 4G architecture. So with this, the second enhancement I told you is control user plane split architecture. That is, you are splitting the functions of control plane separately and user plane separately. So why you want to split this user plane separately and control plane separately? First requirement is larger volume data support. So 5G, more applications, more users going to come. Each user is going to handle plenty of applications at the same time, so it has to support the large volume data support. Rich communication services. So nowadays, due to the growth of this online OTT platform, you will be using the enormous bandwidth if you are going to deal with the video. So all such services has to be provided with low latency and no any kind of discontinuous between watching such kind of things. So that is what rich communication services. Next one is customer should feel better with the whatever the network operator providing experience, and all the things you want to receive as fast as possible. That is within 1 to 2 millisecond of delay, which I already told you. So advantages, again, increase the data traffic, reducing latency, and so the locating and scaling the control and user plane is you are separating that. It is for your scalability and for flexibility and for easy deployment. So independent evolution of your control plane acts separately with the help of control the services connected to the control plane, and user plane acts separately. Okay, the same thing is happened in even in 4G, because the serving gateway and PP gateway does, but here it is somewhat you had a better customer better experience has been faced in the 5G, which is not achieved in the 4G. Next one is obviously everything here you are converting into a network functions, and all the network functions have been virtualized. So everything is acting like a separate virtual container or virtual every function is acting like individual servers. So everything now it is completely software defined. Your complete code network is which is completely a fully virtualized, and it is fully software defined networking. Due to this software defined networking, so new services, even though in the future it emerges, it is easier for the user plane to deliver the service more efficiently without creating any issues and problems. So with this, so the CUPS architecture, okay, splitting control plane and data plane. If you take control plane in 4G LTE, the major key point issue you see here is mobility management entity in 4G LTE is that has been replaced by two functions, AMF and SMF of 5G. Now, this is the major enhancement with respect to the control plane. Whereas in the data plane, if you see, it decouples the packet gateway and the packet gateway in the control and user plane functions. So this I'll explain with the proper diagram so that you will be having a better understanding. So you see here the hybrid core architecture, okay, or the 4G interconnection architecture. So if you see here, okay, so this is the 4G architecture. So this is ENB. It has been written as GNB. So this side, left side is the 4G architecture. So your user equipment or your mobile, it has been communicated. So 4G, it is a base station is nothing but E node B. So this is ENB. It has been communicated here. That has been communicated with MME. Okay. Right side, if you take, this is a 5G architecture. So GNB. And MME has been replaced into two functions. One is AMF and another one is SMF. These are the two things. It is these two functions plays a similar role compared to your MME. And the serving gateway, okay, serving gateway here is user plane, you have a separate serving gateway, and the control planes, you have a serving gateway. That's why you call this red color line splits into control plane and user plane. This is what CUPS architecture. You're splitting even the serving gateway has been split into your control plane and that side your user plane, so that there won't be any issues between the control plane and the user plane itself. And these S6 S11, these are the interfaces, okay, with respect to, here we call everything as a nodes, okay. In 4G we call everything as a nodes. So for example, S1C, so S1C is the interface, okay, between the GNB and MME. This is something related with control plane, so that's why the C stands for control. Whereas same S1 interface, you have this S1C interface with the user plane also, that's why S1U interface. So this is a serving gateway for the user plane, that's why the interface is S1U. And you have a S6A interface between MME and your HSS. So if you take this function, okay, this side if you take 5G, GNB, and all the 5G network interfaces have been represented by N, okay, given the subscript as in some books, it in some papers you would have been seen as NG, next generation, okay. So N2, N3, these are the interfaces between the functions, between the functions in your 5G. So when you are going for the hybrid core, that is with one architecture, I can able to access both 4G as well as 5G. That time you can go with some interconnection. What I'm doing is I'm combining the functions of both my 4G and 5G. So if you see here, UPF is a 5G function, user plane function, okay, and whatever this UPF is doing, the same thing programming gateway is doing in your 4G network. So I combined these two functions. Okay. Similarly, S5A interface, suppose if you are going to operate a hybrid core network, you want to switch between the 4G core to 5G core, then between the user plane gateway and programming gateway, this is the interface. So here this function has been combined. Similarly, SMF, I told you, session management function. Okay, session management function takes care of all your dialogues, control, session management, all those things. The same thing in 4G, PDN gateway is doing the same thing in the control panel. So PDN gateway is, PDN is packet data network. So both the two functions have been combined. And PCRF is nothing but the policy charging function in 4G, whereas PCF in the your 5G. Similarly, HSS is your home station system in 4G. It take care of your all your subscriber information or user information, and UDM does the same thing. So I'm combining this. So in this way, it is possible to migrate to a hybrid core architecture. With a single architecture, you can enjoy both your 4G and 5G services, or you can realize the functions of everything 4G and 5G. So this internet connection between the 4G and 5G, this paves the way for the deployment scenario. Whether you can go for a standalone architecture, that is separate 4G architecture or a separate 5G architecture, or else you can have a single architecture, you can have both 4G or 5G, that is standalone or non-standalone architecture, that will be discussed in the future slides. So with this, okay, we have seen the basic architecture of your 5G core architecture and what are the major functions, how this 5G functions, it has been evolved from the 4G core, and what are the differences between 4G and 5G in general. Suppose if you are going for combined hybrid core architecture, so what are the major functions has to be combined, okay, so that you can have your a hybrid core architecture possible for the interconnection between your 4G core and 5G core. Okay, here I am giving a pass. If you have any doubt, you can ask me. If any questions, you can ask me till now. So any questions? So can I continue with my
you can continue.
Okay, so I'll continue with my presentations. So we are now clear with what are the major components or major blocks or major functions present in the 4G core and 5G core, but we have not deal with the interfaces. I've just given us some number S6, S11, those things. So now we will be seeing in detail about the interfaces. So with this, we'll move on to the, one second. Okay, interfaces. So 5G network interface. So here lot of functions are involved in the control plane. So definitely more and more functions, there will be more and more interfaces. So as far as I referred, nearly some 15 network interfaces were there in your 5G NR radio. I'm not going to cover all the things. I'm going to just cover the very major interfaces. Okay. So I classified my interfaces on the 4 different classification. One is the interface between the RAN node. Okay. So RAN node is nothing but your radio access network. That is, here it is GNB, right? Between the GNBs, there will be different base stations or different GNBs. So between the base stations, how the one base station is connected with the another base station using this X interfaces. Or XN, you can number X2, X3 like that. Okay. If there are plenty of GNBs connected, then it will be N will be 1, 2, 3, go on. Next one is between your GNB, that is your base station, and core network, what are the interfaces? That interfaces S1. S is a subscript you have used in mostly in 4G networks. We have used the subscript S, whereas in 5G we are using NG, next generation, or in some cases we are using just N. Okay, I have used just only N. And next one is interface for function split and open interface. So this I'll tell you, I'll explain you this interface with the diagram so that you will be having a better understanding. And last one, between your physical layer and the radio. This physical layer and the radio means you have a GNBs. Okay, GNBs, many antennas are there. So how the antennas are connected with your GNBs? That physical thing, some physical air interfaces. In 2Gs and all, you will be talking about some air interfaces. That air interfaces comes under this 4th classification. With this, now you see this diagram. Okay, the entire 5G core network I circled into a core network. Okay, this NG, this is the first interface. Okay, between my core network and between my access network. Access network in 5G is GNB, right? That is called NG networks. Okay, there are N number. Here I have shown the 2 GNBs. Okay, 2 base stations or 2 GNBs here. Like that you have plenty of GNBs connected together. So between the GNB, I told XN interfaces. Okay, second interface, XN, X1, or if one more GNB is there, it will be X2, X3, it goes on like this between the GNB. Now, GNB itself I connected, I divided into 2 parts. One is data unit, handling the data part, and another one is control part. Control unit. In data unit, even though there are many layers are there, I have taken the major functions, that physical layer. So from this physical layer, that air interfaces, the 4th interface, whatever I told you, interface between the physical and the radio, all those air interfaces will come here. I have not covered the air interfaces right now. Okay. Next one, MAC layer. This is nothing but your data link layer. So medium access protocol carries out all the data link layer function. Next one is your the RLC. Okay, radio logic control. So this also your data link layer only. So data link layer itself divided into medium access and RLC layer. Now this is your control unit. Control unit, you have the control unit for separate user plane, separate control plane, because in the architecture itself I told you, you are splitting the functions into user plane function and for your control plane functions. So the control unit also, if you see in this diagram, okay, you have a serving gateway. In case of 4G, if you see, serving gateway for control plane separately and the serving gateway for the user plane separately. This is one reason why you are splitting your control unit, GNB control unit, into the control plane and the user plane. So between one particular GNB unit, control plane and the user plane, there is an interface called that interface is E1 interface. So every GNB control unit, between the control plane and user plane, you have the E1 interfaces. Next one is how this control unit has been connecting with your data unit. So 2 interfaces. Okay, control plane is connecting with both the data unit. C stands for the control plane, whereas if the user plane is going to communicate with your data unit, then F1U. So only 4 interfaces. Even though there are plenty of interfaces is there, have been classified into only this major interfaces. First one is NG interfaces. NG interfaces is nothing but interfaces present between the different functions in the core networks. In my first diagram I showed you N, capital N, NRF, capital N, all those things comes under the NG interfaces. If you have that If you have the plenty of GNBs, then all those GNBs are connected to XN interface. So this is the second interface. Third interface is between the control unit, user plane and control plane are communicated with the E interfaces. Okay, so depending upon the number of GNBs, E1, E2, E3, you will be getting. And R interfaces I neglected right now. And the control unit and the data unit are communicated with the interfaces number F1C and F1U. So these are the very basic interfaces you have to know. If you want to know all the interfaces, then you can have a deep reading based upon your interest. So with this, so far we have seen the basic core network architecture and how it evolved from the 4G network architecture, and we have seen the very basic network interfaces in the 5G. Now next thing is
So
how you are
Satish,
going.
Satish, let me just interrupt you. So as we move on to the next topic, there is one query as to whether you can give examples of user and control plane functions.
Yeah, I can give the user and control plane functions. So user plane functions, yeah, as already I told you that there are plenty of 3GPP and non-3GPP services. So if I mention only 3GPP services and non-3GPP services, you may not be knowing, but you have come across these words in case of your 4G communication, that is non-3GPP internetworking function. So that is N3IWF. So this is one application. Okay, that means different internetworks will be there. How that internetworks have been communicated with your user plane. So this one example I can give you. And another one is you would have come across the wireline access gateways. Okay, in case of 4G. So these are the examples for your user plane functions. Regarding control plane functions, so control plane functions I can give you. So based upon what kind of, suppose control plane functions, plenty of control plane functions are there. Anyway, that I am covering in the end of the slides. If you could please wait till the end of the slides, I can give the practical examples for the control plane functions. Any other doubt?
There is one more
And
doubt.
somebody has asked PCRF is controlled by whom? Okay, PCRF is controlled by in some cases it will be even controlled by mostly it is controlled by control plane. Otherwise, okay, I'll answer this question with the help of diagram so that you will be having a better thing. Then any other question? Okay, so how the PCRF is controlled and what is the role of UDP in 5G technology? Okay, I'll answer these questions with the help of diagram. Okay, I'll moving on to my slide. So now you can able to see the slides. Okay. So first question is, who is controlling the PCRF? Okay. So the PCRF is controlled by, if you see here, the PCRF comes under policy function. It is controlled by your subscriber management. So in subscriber management is nothing but UDM. That means UDM and PCRF are combined together. Otherwise, UDM is controlled by your PCRF or PCF is controlled by UDM and vice versa. UDM is also controlled by policy. This further I can replicate in this particular diagram also. You can see an interface N10. Okay, communicating your UDM with your programming gateway, and your PCF has been communicated with your AMF. So AMF, finally, if you not going in deep on the overview, if you see, AMF is controlling both your PCF and your UDM. Okay, so that's why the corresponding interfaces also I mentioned here. I forgot to tell you here. So the PCF is controlled by your programming gateway, because based upon the PDN data you are using, okay, based upon the policy, you will be using your data network. So PCF is controlled by this one also, or else your PCF is controlled by AMF. Okay, this AMF is again controlled by your UPF also, because in 5G, if you take this diagram, you have a common interface. Okay, so since there is a common service based interface, hello?
Yeah, sir, actually, wherein 4G, the PCF actually in the control plane, actually wherein 5G actually to be interface with the user plane, no?
Yeah. So
Yeah, okay.
for, if you take in 4G, okay, MMA is taking care of all the things.
Yeah, yeah, yeah.
Okay, whereas here AMF and SMF, two things are there. So it is going through some intermediate functions here. The same thing, it is going through some intermediate functions.
Ah,
Since it is
okay.
traveling, since it is sharing the common interface, so either communicate directly through AMF or through this way kind of thing. Okay, so two possibilities are here possible. So
Okay.
with this 5G NR interfaces, now we are going to the deployment scenarios. Okay, deployment scenarios, two configurations are there. One is standalone configuration and non-standalone configuration. So standalone configuration, non-standalone configuration, this is the diagram. Okay, that means if you see the left side non-standalone, user equipment, you have a separate LT. This part represents the radio. Here 5G NR is there, that is, this is your GNB. Whereas here LTE you have your ENB. So you have a separate radios even though if it is a standalone architecture. But the core network is common core network. So what happens here is if you see there is an in-between line between your LTE ENB and your 5G GNB. So what happens is this acts as a master node. I'm not saying like the master slave relationship here. Out of these two, this acts as a master. This gives the this dictates or this gives everything in whatever this is dictating. 5G NR has to obey this one because since this acting as a master regarding signaling protocols, because first your access network has to be established. All your signaling protocols has to be established. For signaling thing, 5G NR is completely depending upon your ENBs in case of non-standalone architecture. Whereas regarding your data, okay, directly it can communicate. It is not communicating through the relation between your ENBs and your EPC. Whereas the 5G, this GNB can for data or core network, it can directly communicate with the EPC. Whereas regarding the signaling kind of thing, first to establish the link, it is depending upon your ENBs. This is just non-standalone architecture. This dark line represents the data plane and the shaded line represents the control plane. So if you see here, okay, there is no control here, only data plane is there. So whatever the data sending, data it can receive. Regarding control, okay, all signaling protocols, there will be some signal system, lot of protocol checks will be there regarding signal. All those things, it has GNB has to be depend upon ENB. That's why in non-standalone architecture, ENB acts as a master node. Whereas if you consider a standalone architecture, EPC 4G separate architecture, 5G separate. This is standing separate, this is standing separate. So each one they have its own data plane and control plane. So 5G NR for signaling thing, it no need to depend upon LTE ENB here. It can directly, it have its own GNB, it can communicate directly. So this is the difference between the standalone and non-standalone architecture. So with this, so this is okay based upon architecture wise. Okay, if you are going in the cell layout, like because what about the cell size of 5G LTE and 5G NR? So cell layout, either it can be a homogeneous medium or it can be a heterogeneous medium. First, homogeneous means what? Both LTE, 4G LTE cell size and 5G LTE cell size are of same size. If it is a radius of 5 kilometer, then this is also same size, 5 centimeter radio kilometer. So homogeneous one deployment is possible. You can have both LTE cell and 5G cell as same size. So at that time, coverage is also medium and capacity is also medium. Okay. Now you didn't expect anything. Very good things. So medium coverage, medium quality. Next one, heterogeneous. In heterogeneous, two things are possible. Either you can have your LTE cell size big and your NR cell size small, and the vice versa case is also possible. So homogeneous, when the LTE cell is macro, very large, that time, so when LTE cell is large, which whatever the cell size is very large, that cell will take care of the coverage issue of the network. Whatever cell size you are taking very small, that takes care of the network capacity. So here the second case, 5 NR cell size is very small, so that 5 NR takes care of your capacity. Whereas the third case, heterogeneous, vice versa case, here the 4G cell size is very, very small. So that takes care of the network capacity. Whereas the 5G cell size is macro. So here the 5G cell size takes care of your coverage issues. Whether either the in heterogeneous case, whatever the case, two cases possible, in general, okay, whether a 4G cell can act as a hotspot or 5G cell can act as a hotspot, means we are giving the first preference to the 5G NR cell to act as a hotspot. Okay, these are the two different architecture. These are the possible layout configuration when you are going for the deployment scenario. So whatever the cell you are using, if you want to turn on the hotspot, only the 5G NR cells we are giving the first preference to act as a hotspot due to the lot of emerging architectures or a lot of enhancements it has been made in the 5G architecture. So this has been provided the hotspot scenario. Okay, so with this, now we'll move on to the QoS parameters. Okay, so before going to this QoS parameters, here in this diagram I shown you. So this is nothing but, if you see, that means from the core network through this control unit and data unit, it is nothing but the flow of packets only. So flow of packets means I didn't talk about this layers present inside a control unit control plane and control unit user plane. Now I'll talk about this layer. So the control unit user plane, okay, so the lower layer are same, that is PDCP. So PDCP is packet data convergence protocol. This you would have come across in your communication networks if you are having any. So packet data convergence protocol, this is responsible for handling the packets from the higher layer to the next lower layers. So it deals with all this quality of service of packets or any if any packet loss is there, all those things has been handled by your packet data convergence protocol. So here this QoS characteristics, so quality of service of your packets is been handling how the packets have been forwarded and routed, and the quality of service is also dealt here. Next one is in control plane, the above layer is radio resource control. So regarding radio resource control, in XDA scenario you would have discussed in the access network. Similarly in the user plane, it is SDAP. This is nothing but service data adaptation protocol. So you leave your service data, packet data. You know the importance of what is the convergence protocol and what is the importance of application protocol. Application protocol means whatever the packets receiving from the top layers, application layers. So here you can apply your application protocols like HTTP protocol, I told you, using the application program interface, all those things here. So application protocol is applicable here. Here convergence protocol means within the package you will be having how you are converging the packets, okay, in one particular thing, in one packet how many frames are there, how you are segmenting or breaking the frames, all those things comes under the convergence protocol. So with this, okay, we are now going to deal with only the SDAP protocol, because here only the QoS plays an important role, how it receives the packets from the application layer and it sends to the lower layers. So with this, I am moving on to this QoS. Suppose one PDU session is there, that is now complete network architecture have been converged to a single layer protocol data unit session. From the user mobile, some data have been sending. Finally, it has to reach your background data network. So in between you have core network, this is access or whatever it is. Now we are seeing the data, how the data is flowing. Data is flowing in terms of packets. So there will be n number of users. Okay, each user will be sending their own packet. For every user, I am giving one flow ID. That is one. This violet color represents single user. So single user. So this is nothing but inside this protocol unit, there will be a plenty of fiber optic links. Each link, one fiber optic links will be handling n number of users. Okay, in that one you consider this is a one fiber optic link. In that one user, I am giving some flow ID S1, or one fiber optic link, I am giving flow ID 1. Like that, I have n number of links inside this PDU session. So n number of mobiles present here, n number of users there, everyone is given on ID, they are communicating with the data network. So the first thing is 5G QoS identifier. So 5G quality of service, or so each user they will be sending their own flow of packets. One user will be seeing OTT platform some video, so there will be a continuous flow of packets. One user will be seeing having a video call or a conference call, so he also will be having a flow. So voice traffic is different from that data traffic or OTT traffic, everything. So each user we are giving separate QoS identifier. So based on this, it will handle the traffic, all the traffic related issues. Next one is allocation and retention priority. So allocation and retention priority is, for example, right now 4 users are there. Now suddenly a 5th user is entering into the network. So already it will see the 4 user what type of data traffic is going. Then it will see the what this 5th user who is newly entering into the network, what kind of service is asking. Okay, whether the service is been given immediately or he has been put into the wait mode, given with some priority number, wait list 1, 2, 3, all those things it is been handled by allocation and retention priority, ARP. Next one is reflective QoS attribute. Okay, in the first slide or in the beginning slide, I showed you the communication, comparison between the 4G networks and 5G networks. In that, if you want, I'll go back to those slides to have a better understanding. Here I showed for data link some separate spectrum efficiency, and uplink I showed some separate spectrum efficiency. So keep this in mind. Okay, now we will go on to this one. Okay, so the reflective QoS attribute, that means in downlink communication you have a separate QoS attribute, in uplink you have a separate QoS attribute. So if you have studied 4G core network, you would have known that in downlink scenario you will be using this parameter, reflective QoS technique in the downlink, whereas in the uplink QoS you will be using a new QoS. That means whatever in the downlink, the quality of service, because whenever you are downloading some data, the quality of service handled by the downloaded package is different from the whatever the data if you are uploading, some user is uploading. So both different are both packets, upload package or the download package, it has been dealt separately. So the frameworks, okay, kept for the uploaded package and the downloaded package are different. No, they are not same. That's why the name reflective QoS attribute. Next one is flow bitrates, aggregate bitrates. So the flow bitrates, you would have come across the name like GBR, non-GBR. So GBR is guaranteed bit rates. That means in the same comparison diagram I showed you the peak data traffic. So always you won't be having the peak data traffic. Suppose if you are having 10 Mbps, you can't have a peak data traffic of 10 Mbps all 24 hours. Sometimes you will be having an average data bit of only 1 Mbps or 2 Mbps. That is what given in the flow bit rates. Okay, so guaranteed bit rates is nothing but it is an average bit rate. So average, I can assure that I'll be having a connection with 1 Mbps speed. Non-guaranteed bit rate means sometime if the traffic is very low, no congestion is there, that time I can cross my guaranteed bit rate. That time I can attain my peak data rates, that is 20 Mbps or 10 Mbps speed, whatever is. Same thing aggregate bit rates. Okay, in 4G already there is a concept called carrier aggregation. Okay, I'm not talking much about the carrier aggregation, just I'll give the introduction to the carrier aggregation. The carrier aggregation is nothing but there will be a plenty of users. Okay, so each user you will be allocating in the multiple frequency blocks. Okay, in case of in your carrier aggregation, so you are combining every users, each user you are giving on separate frequency or separate carrier, you are combining every user so that okay, your bandwidth is reduced. Okay, you can allocate more users within the bandwidth and you are increasing the user capacity or the network link capacity that you are using with the help of carrier aggregation principle. This already is there in 4G. The same thing you are applying in 5G also. When carrier aggregation comes into picture, there again when you are combining n number of users together, how you are going to handle the different data rates of the 10 user, there comes your aggregate bit rates. Again there are different types under aggregate bit rates. I am not touching those things. Next one is maximum packet loss rate. So if you take packet loss, suppose if I'm sending 100 packets, okay, 100 packets, how many packets I'm going to lose it? Suppose in voice call, sometimes the receiver, whatever he is speaking, the sender cannot able to. So sometimes in case of a voice call, 100 packets we send in the 4G voice call services, sometimes 80 packets only receive successfully. That's why you ask repeat talking. Whereas if you go for your online data services, or if you're streaming videos kind of thing, there you can't have such heavy losses. There you, for 100 packets, there you can tolerance limit of 1 or 2 packet losses acceptable. That is what specified in the packet loss rate. So out of 100 packets, depending upon your application, whether the 4G voice traffic or a video traffic, whatever else, how you are defining the tolerance for the loss of packet or a delay of packet, what is 1 packet loss or 10 packet loss, how you are defining the this tolerance limit depending upon your traffic. Okay, these are the major QoS parameters. Based on this, you are saying the quality of service of your uplink, quality service, and downlink, or you are rating your service provider, whatever is here. Okay, the service provided by the network provider has been rated based upon this kind of parameters. Next one, characteristics. Already I told you about this one, resource type. So resource type means again flow bit rates. Okay, there comes the guaranteed bit rates. Okay, non-guaranteed bit rates, or the delay critical GBR. So this delay critical GBR, very rare cases only. That is, if you have a this is like average bit rates. This is like a peak data rates or whatever you have. Next one, priority level. Already we talked about the priority level. In the priority level here, you will be giving the numbers like a QoS flow ID. You have given the numbers here. The priority level also some numbers are there. Okay, those numbers will be given here. If you go for the proper frame format for the 5G packet data, there you will be having much information about this priority level. Next one, packet delay budget. Already I talked about this frame packet loss rates. Okay, the budget analysis of complete packet delay in case of voice traffic, video traffic. In video traffic itself, many things are there. Online streaming video or any already recorded video, you non-streaming video you are seeing, there are plenty of things are there. The complete budget analysis of packet delay for different applications. Next one, once you know the packet delay, then obviously you will be knowing, you will be calculating your packet error rate. For 100 packets, 1 packet is lost, then what is the packet error rate? Okay, 99.9 percentage. Hello? Yes. Any questions? So can you please tell me what kind of deployment? Okay, standalone. Okay, fine. So now I'm going back to my presentation. Okay, so these are the important characteristics and the parameters have to be kept in mind when you are seeing the quality of service for the whatever the packets flowing in your NG radio from the application layer to your lower physical layers. Now important thing is, I told you the third thing is, so we have discussed about the service based architecture and CUPS architecture. We have discussed about the interfaces and deployment scenario. We have not talked anything about the virtualization. So what is this virtualization? So virtualization is nothing but, okay, all the functions. Previously I told you functions. Now a particular network, you have plenty of functions like AMF, SMF, all the network functions now have been virtualized. So what is this virtualized? Virtualized is nothing but it is completely software controlled, software defined. Each function now act as a server, independent server. Okay, if each function acts as an independent server, then only you can communicate with, because all the interfaces have been connected to a common control plane in the 5G core network architecture. So whatever the server, suppose I want to access PCF, then PCF is a separate server. I go there, I directly communicate PCS server, I can get whatever the information. Similarly with AMF, SMF, related with network related information or subscriber info, every functions here virtualized and it acts as an independent network, big servers run by your service provider or the network provider. So before going to this is a complete diagram. So the four your complete your network function virtualization has been divided into the 4 layers. The first layer is network function virtualization infrastructure. So this includes virtual switching and COTS servers. So the COTS servers nothing but here it has all the things like what are the hardware resources, what are the software resources, okay, in software resources whether any upgradations are required, all those informations will be kept here. Even though what are the network interfaces, all those informations have been kept here. Second layer is virtual function network. So we have seen the different functions in your 5G core network. I have just kept the major functions here: AMF, UDM, UPF, PCF, SMF. So there are plenty of 78 functions are there. All those functions are virtual functions network. Third one is OSS, operation support system or based business support system layer, and these are the corresponding interfaces with the fourth layer, that is MANO, management, and MANO is nothing but example, one second. Okay, MANO is nothing but management orchestration layer. So as I told you already, the lowest layer, first one is NFV infrastructure. So we'll see. It deals with all the hardware. Hardware resource means what are the routers you are using, what are the firewalls you are using, all those things comes here. Next one, virtualization layer. Next one, virtual resources. So what are the virtual resources means again software resources, and how the software defined networks have been defined here. How we have some informations you have to store automatically. So what are the informations have to be stored automatically? All those things have been dealt with the NF infrastructure layer. Next one is above layer is virtual network function. The virtual network function is nothing but individual functions we have seen here. Element management system. So element management system is what type of element you want. You want subscriber information or subscriber related service, that is one element. Or if you want any network related element, then network if element is word is replaced by network management system. If you are signaling related anything, then signaling the element is replaced by signaling. So we have seen some 5 to 6 services in the service based architecture. All the services can be put over here. The above layer is the operation support subsystem or a business support layer. This is just a top layer similar to your application layer. The fourth layer is a management orchestration layer. So this consists of again 3 components. This we will see in detail with the help of this diagram. And this in between things are the interfaces between your MANO and the so this is a OS layer, so OS and MANO MA. So this is the interface between this one. And the service VNF infrastructure, this is an additional layer which is not or optional layer which is not predominantly present in most of the network virtualization. So whenever this NFV need additional backup support, that time you can have this layer. So all this layer have been communicated with your MANO. So MANO is nothing but your management and orchestration layer. This is nothing but your software lifecycle management you would have studied if you are studying this MANO layer, or the MANO layer functions are similar to your software lifecycle deployment. Because if already available network, you want to expand that network, then you will be introducing some new hardware. Okay, if you are introducing the new hardware into the already existing system, then you want to design, or you want to design, you want to put this, you want to insert this new hardware into already existing system by without disturbing the other thing. At the same time, it has to manage the power issues and other resources efficiently. How you are going to do that? It's very difficult. That's why the reason for virtualizing all the network functions, so that everything will become a software dependent. If it is everything is a software dependent, you can upload the versions of the software so that the hardware components are not disturbed. So this is what the advantage of this network function virtualization. So what happens, there are VNF managers based upon the virtual function. I don't know what, depending upon the particular application, the particular virtual function will be communicating with the control plane. So that will be informed by the managers. Otherwise, you can say this MANO layer is the very top layer, master layer. It will instruct okay, depending upon what functions it will instruct these three layers. Okay, this is a major layer, or the master layer is a manual layer. This will instruct this three layer. This will do the rest of the operations. Like this is a supervisor, these are the team people working under the supervisor. So based upon the virtual functions what it has to, it will be informed to the virtual network function manager. They will be informing this one. So based upon the function, it will be given to the orchestra. So based upon the service, because UDM, TCF, UPF is a user plane function. From the UPF, you will be knowing what kind of user service it is, voice service, video service, or what kind of thing. So that will be known to the orchestra, and that will inform the virtualized infrastructure manager. So this is a very important information. So you have to store this in. If something, anything related to user related information, like a subscriber identity, INC number, or any user authentication, some security key has to be stored, then it will that will be informed by the VNF manager. It will orchestra means he will arrange that that work will be arranged by this will inform to this will perform that work through this interface. It will inform the virtualized infrastructure manager. This will further inform here. So you have to store this information. So for this particular service we need the hardware support. For this particular service we need the software support. This particular thing is needed. This particular thing has to be computed. So in this way, this master layer works based upon the information received or sent to the sub layers or to the team players. Okay, with this, so we have seen the complete picture of your network function virtualization. Now virtual network function. In the beginning, somebody asked me that what are the examples of control plane functions. So these are the examples. Whether the control plane, you are going to deal with any edge related services. Okay, then broadband remote access server will be acting here, or your IP edge. Or if you are going to deal with any switching related services, then switching related services, if you have worked in the switching, you would have come across this gateway, network gateway for broadband network gateway, BNG, or a carrier grade network address translator. Then this network functions it will be operated. Or if you are operating any signaling related thing, session border controllers. That means there are different ENBs, here it is GNBs. Every GNB it has its own coverage or border. If there are plenty of N GNBs, then you want to know this GNB1 has a border coverage of only this radius of 5 kilometer. GN2 it has a coverage radius of this one. So GNB1 and GNB2 it is intersecting for 1 kilometer. Both GNB1 and GNB2 is giving coverage. All those signaling related thing if you are handling, then this will act as a virtual network function. If you are going for mobile network nodes, you all know what is HLR, MME, SGN. Each one will act as a virtual network function. This each one will act as a servers. Next one, network wide functions. So network wide functions, AAA server policy. So AAA is nothing but authentication, authorization and accounting. This is regarding user authentication, or if you want to store the user accounting, anything with this, all those informations it will be. And charging platforms, or he is a postpaid customer or a prepaid customer, what are the services you are using. For this services he is charged this much. All those things are network related or operator related functions. With addition to this, you may require some fire loss or some detection systems or wireless scanners or spam protection. If you are selecting this particular thing, then that particular thing will act as a virtual network function. That's why in the previous diagram I have shown some 3 or 4 layers. I don't know how many virtual network function managers will work here. Examples of virtual network function is given here. So out of these many possibilities, what are the things you are accessing, those number of virtual managers will be coming into the existence. So with this, okay, virtual network interfunction. So we have seen already this one, EMS. EMS is the element management system, comes under your top layer, and this is your infrastructure layer. In between is your VNF layer, virtual network function. So I told you that the plenty of virtual network function is possible. So between the virtual network function, we are using the interface SWA, and here the SWA is just a notation we have used here. See, for some notations we have mentioned VNNF. Okay, for some notations, in order to have a clear thing, I've used the notation SWA. So all the different types of virtual network functions, all the plenty of network functions will be communicating with your virtual network function manager. The same diagram, okay, this diagram, this part alone, okay, this part alone have been given a separate diagram. Okay, so here I showed just two virtual network functions. This can be plenty of virtual network functions. What are those possible network functions has been listed out here. Okay, so once you are successful with this network function virtualization with the help of this VNF managers, it is possible to do the network slicing. So this is the third major enhancement in your 5G core network architecture. So you have your 5G RAN network, that is radio access network, you have a 5G core network. Okay, what is network slicing? Slicing means something cutting. Okay, what are the different types of services you are offering here? First, a very low thing, voice services. So whether the user is accessing any voice related services, so voice related services major, when you are designing that particular network, the major parameter you want to look is low latency voice and signaling with guaranteed quality of service. That means guaranteed quality of service means there should be some average data rate so that there should not be any misconception or any packet loss when the person is using the voice services. So depending upon the services, your design requirements is varying here. Suppose if you are going for smart network, smart metering network, here the larger number of connected devices. Suppose you are controlling some devices in your home, you want to shut down your laptop, or you want to switch off the fan, or you want to switch off the any automation devices like your washing machine kind of thing. So plenty of devices connected with your mobile phone. With the mobile phone, you are going to operate those devices. That time, okay, the minimal network activity, you are not going to waste the network resources. So network activity is very minimal, and the data requirement also, whether to switch on or switch off. So the data requirement is also very less. But at the same time, it has to support larger number of devices. So your phone should have a capability of maintaining 4 devices at a time, or 5 devices at or 10 devices at a time. So here the larger number of connected devices comes into the picture. Suppose if you are going for vehicle to vehicle communication or device to device communication, there latency is very low latency is required, but the communication should be critical. There should not be any communication should not cut off. Like suppose if you have a multi-party player games, if you have 5 or 6 players are playing, suddenly one person is losing. Okay, no problem. That one person he can connect and he can enjoy the thing. The such kind of things, it's not possible in case of this scenario. So once based upon your 5G application or this one, what kind of application, every application, the particular design you are choosing, there you are slicing the network based upon your requirements. Okay, you are this network slicing is possible so that you can accommodate more number of users or the more number of connected devices. You can give the better data rate, at the same time you can maintain better link capacity, whatever else. So with this we'll wind up this session. Okay, so in this session we have just introduced what is a basic core network architecture, what are the components present in that, what are the air interfaces present in this one, how to have an interconnection between your 4G and 5G network. And in 5G network, 3 main things are important. One is the service based architecture. We have discussed the service based architecture, and this control user plane split architecture, and third one is network slicing. For this network slicing, network function virtualization and VNF, virtualization network function managers are important. So we have seen this 3 key enhancement in detail, so that we have covered all the basic components and architectures of the 5G core network. To have a deep insight, and you can have a deep reading based upon the participant interest. Okay, with this I'll wind up this session and I'll reply to your questions. So So can you please give some idea what kind of 5G deployment is going around on the globe, standalone or hybrid architecture? So it is everybody is looking for standalone architecture only. If you are going for standalone architecture, then it is more cost is more. So in some cases, on some applications, there might be a cost effective case. There you can go for this non-standalone architecture. So this depends upon only the user, what kind of service, and is cost, everything related. Okay, so you can go with it depending upon the application. You can suggest or designer choice. You can go for either a non-standalone or a standalone architecture. Any other question? I think I've given the examples of user and control plane function, and I said about the role of UDP in 5G. Okay, any questions?
There are a couple of questions in the chat box, Satish.
Will our SIM card and phone be upgraded to use 5G like we had? Yes, your phone has to be upgraded, definitely. SIM card is not necessary, but phone definitely it has to be upgraded. That's why 5G phones, we are not completely open to the 5G. Even though 5G phones, whatever you're seeing in the market, they're planning to operate with both your 4G SIMs and 5G SIMs. Okay, definitely phone has to be upgraded.
Just Satish sir, can you do you have a
Please
slide? Yeah,
once more show the difference between the rate and bandwidth etc. in 4G and 5G. Okay, I'll show the slide. Okay. You were asking 4G 5G comparison, right? So this is a 4G 5G comparison. So data rate is, I showed here the average data rate, not peak data rate. Latency, targeted latency. Mobility is how much the region it is covering in 1 hour. Okay, that is a mobility, you can travel. That one. Spectrum efficiency, you all know, ratio of data rate or your throughput to with your respect to your channel bandwidth, RB divided by bandwidth. Okay, that's why the unit downlink and all bits. Numerator it is data rate, it's bits. Denominator is a bandwidth, it is represented in hertz. That's why the spectrum efficiency units is bits per hertz. Okay. User density, how you are accommodating more and more users within the cover, within a square kilometer region. Then obviously 5G has to be energy efficient than 4G. Okay. So how the EM waveforms differ from 4G and 5G? So see, I'm related with this core network. So your question is something related with the access network. Okay. So mathematical thing. So my aim of this session is to just introduce the fundamentals regarding core networks. Okay, this question has to be answered by access network person. Okay, or
yeah,
EM waveforms.
Satish,
Tomorrow, I
yeah,
think
yeah.
tomorrow morning session you are having regarding waveforms, signal waveforms in 5G. So you have a separate session. There, I think this question will be answered.
Yes, and let me just add to that. Apart from tomorrow morning's lecture, there will be another lecture on Thursday at 12 noon, which deals with millimeter wave communications, where I presume the speaker will tell you the difference between traditional microwave signals and millimeter wave signals, even in terms of propagation characteristics, etc. So I think we can wait for that.
So one more question, LoRa, Sigfox and narrowband IoT all comes under 4G or 5G. I'm sure that this narrowband IoT, right? Narrowband IoT comes under 5G. That is, I'm sure. Regarding this LoRa and Sigfox, I'll refer and I'll answer your question. Okay. I have to refer. But one thing is narrowband INT comes only under 5G. That is damn sure because we are working on IoT application. The rest too, I don't have to refer and I tell you. I don't want to convey the wrong information. So anything else?
Hello. Sir,
Yes.
what kind of modulation will be used in 5G communication technology?
Yeah, that modulation waveforms, everything will be dealing with the tomorrow's session. One person is going to deal with that one only. Okay, modulation and waveforms. Tomorrow's session is completely for modulation waveforms. Today's session is only for the core network architecture. Okay, I'm not dealing anything with modulation and waveforms. Tomorrow morning on tutorial and tomorrow evening on video demonstration, that is completely with respect to your waveforms and modulation. Okay, tomorrow if you attend the lecture and your video thing, all your questions will be answered regarding waveforms and modulation.
Okay.
If you want, you can refer your timetable also.
Okay.
So, if there are no more questions, Dr. Satish, can we wind up the session now?
Yeah. So can I wind up how practically NB IoT is taken in India? Okay. Regarding this, I think Friday morning session, we are going to deal with the IoT protocols and how IoT can be implemented in 5G. Okay. You have a Friday morning session, we will be dealing with Prabhu Chandhar from same Chandhar Research Labs. There all questions related with this narrowband IoT or applications of IoT with 5G. Okay. All those things will be answered, and I think they are also going to show some video demo also for that session. There that question will be answered. So once again I am telling you regarding modulation waveform, tomorrow you can attend the session, you can clear your doubts. Regarding IoT, Friday morning session, don't forget to attend the session because that is theory with video demo for particularly for IoT with 5G. Am I right, Shahjahan?
Yes, sir, that is correct. So let me just reiterate. Tomorrow morning, Dr. Chaitanya from Mahindra University will be delivering a talk on 5G waveforms. And then in the afternoon session, you will have a video demonstration of the test bed. And on Thursday, in fact, in the morning, Dr. Swaminathan from IIT Indore will be discussing channel coding for 5G. And then in the noon session from 12, Dr. Lakshmi Narsimhan will be talking about millimeter wave MIMO and massive MIMO and millimeter wave communications. Then Friday in the morning, there will be a session by industry personnel in the morning showing you the basics of IoT before we begin with IoT for 5G, that is narrowband IoT, being one of the technologies that will be taken up by Chandhar Research Labs on Friday. So this is what is in store for the next few days. So Dr. Satish, can we close this session now because we have already
Okay.
finished.
Okay.
Yeah,
Thank
I
you.
thank you, sir. I thank you, sir. In fact, a lot of appreciation has come forth in the chat box, and I'm sure participants benefited from your two sessions yesterday as well as today.
Okay.
And I'm really grateful to you.
Okay.
So now
Thank you,
we'll close
Shahjahan.
this. Yeah, thank you so much, sir. Now we'll close this session, and the next session will begin at 12 noon, where Dr. Praful Mankar from Triple IT Hyderabad will be taking up stochastic geometry for cellular networks. So that is intended to give you an idea of what are the mathematical tools which are used for cellular capacity evaluation. So he will be taking you through the basics to some advanced theory of stochastic geometry, and he is considered to be an expert in that area. So please rejoin the meet at 12 noon today. Thank you.